So I'm pretty sure you're already aware that this equation is for a hyperbola, right? And then you should already know that the a value, right, will determine the quadrants of your hyperbola, right? And all that we are concerned about is whether is the a value, is it greater than or less than 0? So to answer your question in short, right, the way that you go about sketching such a problem is to look at all the properties that they gave you and also use what you know about the hyperbola, right, to come to the correct conclusion, right, or to the correct sketch, right. Okay, back to what I was trying to say over here. Okay, we know that if this a value, right, is greater than 0, then it means that you are in the positive quadrants, right, which is quadrant number 1 and quadrant number 3. Okay, then if the a value is less than 0, then you are in the negative quadrants, which is quadrant number 2 and quadrant number 4. Okay, so now they said something in your question, right, something about the fact that your function is increasing throughout its domain, right? So you were given that the domain of this function is all x values, right, except for when x is equals to minus 2. Okay, you should already recognize that this is going to be the location of your vertical asymptote, right? So they're saying that you can take any of these x values except for the x value of minus 2. Okay, so you can already put down the skeleton of your sketch, right, and say that you are going to have a vertical asymptote here at x is equals to minus 2. Right, so they said that for this domain, right, your function is increasing throughout. Right, so then now that's going to help you to decide whether are you in the first and the third quadrant, or are you in the second and the fourth quadrant, right? So we need to be looking at what is happening to the x values as we move in this direction, right, from left to right. Okay, we're going to look at what's happening to the x values and what's happening to the y values, right? So if we look at this first sketch, right, as you move from left to right, okay, your y values are decreasing. Okay, can you see that? Okay, even check over here, as you're moving from left to right, okay, as you're covering these x values, the y values are decreasing. Okay, so then this case over here, right, is indicating a decreasing function in the domain, right? Now let's look at this one, right? If we do the same thing and we travel from the left hand side, okay, and you look at what's happening as you're increasing in x values, right, you can see that the graph is increasing in y values. Okay, even on this side, as you are increasing in x values, okay, the graph is increasing in y values. So which means that the case that you are talking about, or you need to sketch, is this one right over here, because this one is the one that qualifies for an increasing function. Okay, I'm not sure what else they gave you, so let me just quickly check. Right, so something else that was given to you is that you have an equation, right, of your axis of symmetry, right? This was given to you as y is equals to x plus 6. Okay, you can sketch this on your graph as well, right? It's going to be a straight line with a y-intercept at positive 6, right? So we can estimate it to be somewhere there. Okay, if we want the x-intercept, right, remember that we make y equal to 0. Okay, so if you're going to make y equal to 0, you're going to have an x-intercept at minus 6. Okay, so the line is sloping upwards, right, and it's going to look something like this. Okay, that's going to be one of the axes of symmetry, okay, defined by the equation y is equals to x plus 6. Okay, but now you can also use this to find the position of your horizontal asymptote. Okay, you've already been given the vertical asymptote, right? So now you need to know that in general, okay, this is all about applying the theory that you know. Okay, if you don't know this, you should be jotting it down. Okay, you should know that in general, the equation of your axis of symmetry, well, this specific one where you have a positive gradient, that's going to be given by the equation y is equals to x minus p plus q. Right. So now we already have this x part, so we can just focus on just the minus p, right, plus q. Whatever that was, we know that it ended up being equal to 6. Okay, now we were given, right, this p value, okay, it's minus 2. Okay, so we can actually substitute into here. Okay, so it's minus negative 2 plus something, which is going to tell us our horizontal asymptote, that must equal 6. Okay, so then you have 2 plus q is equal to 6. Therefore, q must equal to 6 minus 2, which is 4. Okay, so which means that you have a horizontal asymptote, right, at y is equals to 4. Okay, now you see this point right over here, okay, where the axis of symmetry intersects the vertical asymptote, right? It must also intersect with the horizontal asymptote. So we'll put it over here. Okay, this is going to be y is equals to 4. Okay, so now just to confirm that your q value is correct, you can do a little bit of a check, right, by confirming that this point negative 2, 4 actually lies on this straight line. Okay, so you can do that little check by saying that, okay, I want to find out what is the y value when x is equals to minus 2. So you take that minus 2 and you substitute it into that given equation of the asymptote, y is equals to x plus 6. Okay, so then we get y is equals to minus 2 plus 6, which is 6 minus 2, which is 4. Okay, so then therefore the point minus 2, 4, okay, it lies on, sorry, this actually should be lies like that. Okay, lies on the line. Cool. Right. So now that you've confirmed that, you can now carry on to just put your sketch, right? Put everything together. Okay. You already noted that this is the shape of your sketch, right? So now you can put it in here, right? And just follow these asymptotes. Right? Just make sure that you don't touch the horizontal asymptotes and you don't touch the vertical asymptote. Okay, and other side, it's going to be like this. Okay, so that should be an accurate enough sketch, right, of your function. Okay, so they required you to show any asymptotes. Okay, so you have, there's your vertical asymptote, there is your horizontal asymptote. Okay, and now you can see that this axis of symmetry, right, just means that if you fold this part of the graph over this line, okay, it will sit exactly on this one. Okay, and other way around as well. Right, it just looks different because we didn't draw this one so far, you know, up and to the left. Okay, so this should be the sketch of your graph.